Every office keyboard, every typing test sheet, every laminated home row chart taped to a classroom wall carries the same sequence of letters across the top row. QWERTY. The arrangement feels personal, learned by individual hands, one finger at a time, and yet no single person chose it for themselves. It arrived already printed on the keycaps, already drilled in the typing workbook, already expected on the job listing. A layout that millions of people practice alone, but that none of them decided alone. That distinction is the whole story. The keyboard on a desk is a visible object. The standard behind it is less visible. The physical keyboard can be replaced in an afternoon. The standard takes decades to move, if it moves at all. A touch typing chart poster in a 1950s classroom and a keyboard shortcut cheat sheet card pinned to a cubicle wall in 1998 enforced the same layout for the same reason. Changing it would cost more than keeping it. QWERTY operates as an interface contract. On one side, a hand trained to reach for specific positions without looking. On the other, a machine built to register those positions and produce text. Between them sit employers who measure output in words per minute, schools that grade students against a speed test timer, and manufacturers who stamp the same legends onto every keycap mold. The contract holds because all sides have invested in the same arrangement. In the early typewriter era, the practical constraints were mechanical. Typebars, the metal arms carrying letter stamps, swung upward to strike a ribbon and press ink onto paper, rolled around a platen. When adjacent typebars fired in rapid sequence, they could collide, jam, and stall the machine. The arrangement of letters on early keyboards was shaped in part by this problem, distributing commonly used sequences across the mechanism to reduce jamming risk. What matters for lock-in is what happened next. Once a layout shipped on enough machines, typing instructors built lesson plans around it. Drill workbooks printed finger position diagrams matching that specific arrangement. Students spent weeks building muscle memory, measured their progress against a classroom clock, and earned certificates validating their speed on that layout. A typing certificate from a commercial school in the mid-20th century carried real labor market value. Employers sorting through job applications could use stated words per minute as a filter, and that number only meant something if everyone had been tested on the same keyboard. Typing classrooms operated with real rigor. Rows of manual typewriters with round glass keytops faced an instructor holding a clipboard and a grade sheet. Drills ran on fixed intervals, timed to the second. Students learned home row position before anything else, fingers resting on ASDF and JKL semicolon, and advanced through the structured exercises printed in thick typing drill workbooks. A student who learned QWERTY had sunk dozens of hours into muscle memory for that layout, and the school had built its entire program, its textbooks, and its reputation around producing graduates fluent in that pattern. Offices absorbed those graduates directly. A mid-century typing pool was an operational unit built on the assumption that every typist shared the same keyboard fluency. Dictation machine cassettes arrived at desks. Typed memos, carbon copy forms, and file folders moved through workflows designed around predictable output rates. Supervisors tracked pages per hour. The electric typewriter, with its correction tape, cartridge, and smoother keystrokes, replaced manual machines over time, but the layout carried over unchanged because the entire office workflow depended on operators who already knew it. Procurement reinforced the pattern from the supply side. Office supply order forms listed typewriters and replacement parts by model number, and every major manufacturer produced QWERTY machines because that is what purchasing departments requested. Replacement keycap sets, ribbon spools, and maintenance receipts all assumed the standard arrangement. A single, non-standard machine introduced friction into ordering, inventory, and service scheduling. Procurement catalog pages from office equipment suppliers in this period show almost no variation in layout. The installed base drove the available options, and the available options reinforced the installed base. Alternative layouts did exist. Some arrived with promotional brochures, key legend comparison charts, and demonstration boards showing reorganized letter positions optimized for finger travel and letter frequency. A few offered measurable improvements in controlled typing tests. But measurable improvement in a controlled test and practical adoption in a real operating environment are different problems. Any alternative had to overcome training inertia accumulated across thousands of classrooms, hiring expectations baked into job listings mentioning typing speed, hardware defaults stamped into millions of machines, and the simple human frustration of relearning where every letter sits. An office manager considering a switch faced the cost of new equipment, retraining manuals for the entire staff, a temporary drop in output, and the risk that new hires would arrive already fluent in the old layout. The calculation almost always favored staying put. The transition from typewriters to computer terminals could have broken the cycle. Terminals had no type bars, no mechanical reason to preserve any particular letter arrangement. A keyboard connected by a coiled cable to a screen and processor was, in principle, free to adopt any layout. In practice, organizations purchasing terminals wanted their existing staff to sit down and start working. A beige keyboard wired to a terminal station inherited the QWERTY arrangement. Retraining costs were real and immediate, while the benefits of a new layout were uncertain and long-term. Training binders and laminated reference cards issued to employees during the transition focused on new commands and software shortcuts, including Control, Alt, and the function keys, all mapped onto the familiar letter grid. Personal computers repeated the same logic at consumer scale. When personal computers arrived on office desks and then home desks, keyboard manufacturers had every technical freedom to rearrange keys. They did not, because every typing course, every secretarial school graduate, and every office worker with a decade of muscle memory expected the same layout. Software shortcut culture added another layer of lock-in. Ctrl-C, Ctrl-V, and Ctrl-Z settled into familiar positions on QWERTY boards, becoming easy to teach, print, and repeat. Printed shortcut cheat sheet cards distributed in workplaces assume those positions. Changing the layout meant reworking shortcut habits, rewriting training handbooks, and relearning behaviors that had become automatic. The original machine is gone. No type bar swings upward in a modern laptop. No ribbon spool needs replacing. The mechanical constraints that contributed to the arrangement dissolved decades ago. The layout remains because it is embedded in something more durable than any single machine: a training infrastructure, a hiring expectation, a manufacturing default, and a muscle memory shared across generations of hands. A layout becomes a standard when institutions train it, markets hire it, and hardware ships it. It becomes hard to move when everyone has already learned where the keys are.